Welcome. In this video, we're going to determine the absolute extrema for this function, that is f of x equals 2 cosine x plus sine 2x on the interval from 0 to pi over 2. Now, I'm going to show you the steps we've been using in our previous videos. So these are the steps we've been using in our previous videos, and that is when we had a closed interval, but here we have an open interval. So we still want to find the critical values and evaluate f at the critical values, but now we don't really have endpoints to evaluate f at. So I'm going to cross that out. And this means we're just going to identify largest and smallest values from step 2. And so I want to point out that we are no longer guaranteed extrema on this open interval, since the extreme value theorem tells us that we're guaranteed extreme values on a closed interval only. So let's begin. So f prime of x is equal to negative 2 sine x plus 2 cosine 2x. So let's look at where f prime of x is equal to 0. That is where 2 sine x plus 2 cosine 2x is equal to 0. Well, the first thing I can do is I can divide both sides by 2 to get cosine 2x minus sine x equals 0. And of course, I also rearrange these. I like having the positive value first on the left. Next, let's use an identity. That is, let's use the fact that cosine of a double angle is equal to 1 minus 2 sine squared x. And then from that, we're going to subtract sine x. So we really have negative 2 sine squared x plus sine x minus 1 equals 0. And now this can be factored. And this factors as follows. So this is negative, and then I'm going to have 2 sine x minus 1, and then sine x plus 1. And this is equal to 0. Okay, so what are my critical values now? So 2 sine x minus 1 equals 0, and sine x plus 1 equals 0. From this one, I end up with sine x equals 1/2. So x is equal to pi over 6. And for this one, I have sine x equals negative 1. Now, this one isn't going to produce a critical value, since the values of x, that is the angles that give me negative 1, are things like negative pi over 2, 3 pi over 2, and so on. None of those are going to be located in our interval between 0 and pi over 2. So I'm going to just eliminate these outside of interval. So my only critical value then is x equals pi over 6. That's my only critical value. Okay, so next let's go ahead and evaluate our function at this critical value. So f of pi over 6 is equal to 2 cosine pi over 6 plus sine of 2 times pi over 6. So f of pi over 6 is equal to, well, cosine of pi over 6 is root 3 over 2, so this is 2 times root 3 over 2, plus sine of pi over 3, since of course I think it's easy to see here that 2 times pi over 6 is equal to pi over 3, and sine of pi over 3 is also root 3 over 2. So f of pi over 6 is equal to root 3 plus root 3 over 2, and this is, what does that work out to be? About 2.6 on a calculator. Now, is this a max or a minimum? However, we don't need the endpoints. This could easily be, say, if this is 2.6, our curve could be like coming down like this, or our curve, if this is 2.6, could also be doing something like that. So I'm going to quickly see what f of 0 is and f of pi over 2, just to double check if this is going up or down. And I'll draw a little mini sketch here. So this is 0, and here's pi over 2. So f of 0 is equal to 2 times cosine of 0 plus sine of 2 times 0. This is just 0, and cosine of 0 is equal to 1, so f of 0 is equal to 2. So 1, 2, 3. Here's f of 0, and then f of pi over 2 is equal to 2 cosine pi over 2 plus sine of pi. And again, this is going to be 0. Cosine of pi over 2 is 0. So here we are. And a pi over 6, which is about here, we are at a little over 2.5. So our curve is doing this here. So I know that is an absolute maximum. And it's located at pi over 6. And there is no absolute minimum. And to make it really clear why, I should actually draw these as open dots. There we are. Because the endpoints are not included. That makes it clear why there's no minimum, since we can get infinitely close to this value of 0 here and not reach it.